Good morning, class. Today, my name is Ashwin Moj, and I'm partnered with Prasin Sarana. And today, we'll be talking to you about free radicals. So, the typical properties of free radicals. For one thing, they are reactive species, usually atoms or groups, which possess an unpaired electron. And the reactivity is due to them wanting to pair up that electron. It's formed by homolytic fission or homolysis of covalent bonds. And it's also formed during the reaction between chlorine and methane, which is known as the chlorination of methane. It's also formed during thermal cracking, and it's involved in the reactions taking place in the ozone layer. Now, as we know, free radicals are very reactive because they want to pair up their electron with sufficient chlorine in the case of the chlorination of methane. And the chlorination of methane proceeds via free radical substitution. This is because the methane is attacked by free radicals, resulting in hydrogen atoms being substituted by chlorine atoms. This is, however, only one example of free radical substitution. The three steps in this chain reaction go as follows: the initiation step, the propagation step, and lastly the termination step. Over the next few minutes, Prasun will be drawing you out, taking you through the steps through a visual means of how these three steps go about in the chain reaction, whilst I will be providing an in-depth analysis of what actually happens in the substances. Prepare and get ready. Now let's move on to the first step of the chain reaction, the initiation step. So we're going to exemplify this through the chlorination of methane. Now, as Prasuna's drawing, this is a chlorine molecule, Cl2, and through the process of free radical substitution, radicals are created. This is in the presence of UV light, and during initiation, the weakest bond is broken as it requires the least energy. During the breaking of this covalent bond, one electron goes to each chlorine atom. As a result, the radicals are created in which the single dots, or the yellow Play-Doh balls, represent the unpaired electrons. This is the process of initiation in the chain reaction. Moving on towards the propagation step. So as we know, free radicals are very reactive because they want to pair up their single electrons. In the case of the chlorination of methane, a free radical of chlorine that is produced in the initiation step is added towards a methane atom. A free radical is therefore produced because of the abstraction of a hydrogen atom from the methane, as demonstrated through this equation. A methyl radical is therefore formed. Along with the methyl radical, hydrogen chloride is produced as a byproduct. Through the second step, we can see that radicals that are generated are reused in the propagation step. The methyl radical produced from the first equation is reacted with a chlorine molecule, thus again producing a chlorine radical. This chlorine radical can therefore react in the same process, and thus we can see that the whole process can be repeated. This is the step of propagation. Excuse my cameraman's horrible work, quite frankly. Moving on to the termination step. The termination phase is basically the phase in which the free radicals are removed from the reaction process. As Prasuna's drawing, an example of the termination process is exemplified, in which the chlorine free radical and the methyl free radical react to form CH3Cl. Therefore, there are no more free radicals present in the reaction. Removing the reactive free radicals brings an end to the reaction. However, this is not very likely at the start of the reaction because of their low concentration. Similarly, another reaction that demonstrates the termination process is the reaction between two chlorine radicals, thus producing a chlorine molecule. Therefore, again, we see that no more free radicals are present in the termination process. Thus, this process removes all the free radicals and brings an end to the reaction. Thank you very much, and we hope that you tune in once again. Peace out.